has entered the room. Oh, I need to push the clicker thingy and the thingy. Is it about time we have another USB plug? These are becoming too ubiquitous.
The USB-Cs?
Yeah, so we need like a USB-D so that we can now have new plugs we don't have the adapters for.
Well, we have to make them start making sense again because now we standardize on connectors, but the actual cable behind them is all like there's 7 different types of cable and you're not quite sure which one it is.
Maybe make it a plus sign or a triangle next time. Something with sharp corners.
Phillips head.
Hey, Robinson. Superior.
J45.
Much superior. Okay, who gets to it?
For the important need to torque out.
I can change it. Just change twice on its own.
Oh.
Yeah.
Anyway, it's time.
That's weird. Hello, ADD. And Tommy Jensen has entered the room.
You know, the other door is locked.
We can start now.
We can start, for Tommy has arrived.
I thought you didn't want us here. The other door is locked.
That's also true, but.
So shall we get started? We would be very pleased and very happy if someone could volunteer to be the scribe and take any action items.
Actually, Lehman has already, but he's not here yet.
Oh, well.
He'd already volunteered to continue his role.
Okay. What do you want to do?
Is there somebody who is willing to, is that maybe Lehman? Ah, there we go. Our scribe has arrived.
The scribe has arrived. We can proceed. Well, once he gets his computer open.
Len will regale you with more
I can't
Princess
do it
Peach
again.
jokes.
It did it again. I did not. That's weird. No, that last one went so badly. I'm not gonna go for it.
Moving up. Good to go, Lehman.
We have the thumbs up. All right. Welcome to ADD at IETF 119, session number 2, the Thursday shift. We had a great morning session. I thought we made a lot of progress, and everybody was really engaged. So well done. Let's see if we can keep that momentum going this afternoon. So once again, this is of course a IETF meeting. Note well does apply. Please make yourself aware of it if you are not by this point in this week. I'm your co-chair, Glenn Dean from Comcast NBC Universal.
Hi, Tail.
We have a most excellent area director. And this is our agenda we're carrying over from this morning. The first order of business will actually be the last one. We're going to have, we're at 3.1. We're going to do, I'm all messed up here.
Take a breath.
Do a breath. We're actually going to start with item number 4, which is the handling of encrypted DNS server redirection. Draft Tommy Jensen and John Todd. And I think there's a third author on it. Tori. You're going to present your updates, little short things after Tommy gets through. Clicker's right here. after you get through it, and we'll then switch back to the architecture discussion we started this morning. But let me bring up your slides, sir.
Sounds good. Thank you.
And I went with the deck that was labeled latest, figuring that was the latest.
Yes, thank you. Hey everyone, Tommy Jensen back. We're here to talk about encrypted DNS server redirection.
Working, not working?
Not working.
Okay, just tell me when you want to advance then.
All right, next slide. So in a nutshell, we made a pretty big update, but it all comes down to one thing, which is now there's only one mode of redirection. It was clear that the working group didn't have consensus for doing anything that allowed you to redirect from one server with domain A to another server that could claim domain, that would end up not being able to claim domain A. So it's not there anymore. All redirections have to stay in the same origin or it can't be authenticated. From previous reads of the draft, that just means that the same origin redirection is untouched. The other method has been removed. That's pretty much it. So we're going to take a few minutes and just go through the list feedback items that came up. Next slide, please. Ben called out that we need to do a rephrase on on service binding record usage, and he's absolutely correct as always. That's pretty trivial. We'll be doing that. Next slide, please. This is a good one. So we talked about using delegated credentials because that's really the ideal way to address the root cause of why people wanted to redirect across names. Is we want to shed traffic off to a third party that we contract with to take our traffic, but we don't necessarily trust with access to our private key. And the good news is there's a standard for that called delegated credentials. Great. The existing text isn't sufficient because it says servers can use it, and that's great, but that implicitly places a burden on clients that they have to expect it because it could happen. So we need to clarify the text and say when it can and cannot happen. That text doesn't exist yet. If you have any commentary about how you'd like it to exist, please let us know. Next slide, please. Clarifying the differences when used with the resolver originally discovered using DDR. Went with the spirit of things when we wrote what we did, which is there's only this one real difference, but Ben's correct. There are other differences, such as the SNI won't have the domain name like it would if you already knew the server's identity without having to use something like DDR. We will add that. No objection there either. Next slide, please. So this is actually a good catch. We had, in the early days when we were developing this, we went back and forth on ideas. And this, the thing we were trying to prevent was having a chain of redirections where they were all decently length except one, and it being so short meant you actually had to come back up the chain and work some things out. And our intention was always, don't ever do that, always start over. But as written, it means that we did that by setting them in so we didn't have to do this constantly. Ben suggested instead we just call the redirection silly and go back. And we're in agreement on that. It's better than TTL stretching, which means we'll need to add some text to the considerations, more strongly pointing out the burden on a server of redirecting through short TTLs. You are about to bring all your clients back if that's not what you wanted. Next slide, please. All right, and so then Manu raised a good point about what happens when the redirection target goes offline. So this was something that I was actually surprised because I thought we had said it and didn't. It was, like I said on the previous slide, it was always our intention that redirections are not stateful along the path. Whatever nodes that a client went through to get to the final destination are not relevant other than we had to authenticate our way through. Once the redirection has expired, we go all the way back to the beginning and start again because that's the only address that we were configured with out of band, and we want to keep honoring that when it wants to change its redirection mind, not when an intermediate changes its redirection mind. This is a different case of the same scenario, which is, the server disappeared. Oh, well, that was the one that was recommended along a chain to me. If that's gone, I go all the way back to the beginning. So we will add text to that effect. So next slide. Thank you everyone for reading this and tolerating our revisions. Given each of these, so this is everything that showed up on the list since the -3, and we have no objections to any of it, and we'll have text out very soon, just not before we leave Australia. And we're ready to request adoption again. We think from seeing this that it's the controversies at a pretty low level. All the issues have been accepted, and the one thing that everyone really didn't like is not there anymore. So happy to take questions. I see an empty queue.
No,
There we go.
other Tommy.
Oh, it's the guy with the loud Samsung device in the plenary.
I'm not the only Tommy here. Okay. Thanks for presenting this. I'm Tommy Polly. I was about to say it. I'm Tommy Polly from Apple. So the other one. So you need to put last names in here now. So apologies for not writing comments on list. I will note I was looking for GitHub to write issues on because for some of the nits that don't need to go to a list, but it's not public yet.
We were kind of playing chicken in the hopes we get it adopted and then
Yeah.
make that the GitHub. But anyway.
So I guess a couple nits as far as how we're referring to DDR, I think is the main issue I have that I would love to see resolved before we adopt, just so that if we adopt a document, it's not inaccurately describing our other RFCs.
Sure.
So like specifically, this document seems to be referring to DDR as the bootstrapping from IP address of an unencrypted resolver, which is one of the modes that DDR supports, but it's not the only mode.
That's fair.
So there are, like, I think a number of times, like essentially, we should probably scrub the whole document for that, and maybe come up with like some good terminology or like a shorthand, say, of like, you know, DDR from unencrypted IP. I don't know what that is.
Well, the good news is the very wise and intelligent co-authors of DDR
yes.
did name those modes.
Right. So we just need to put that name
Yeah.
in more often and use that name instead of the name DDR.
Makes sense.
I think also, you know, some nits around like when we have multiple SVCB responses. I know like somewhere in the draft it does mention like, oh, and there could be multiple here. But that's like listed way down. It'd be nice to explain that further up, and kind of related to that, I'd love to see some like just examples of resource record responses. So like it's very clear when we're talking about I'm doing a lookup based on the resolver name, like what specifically is that and how does that look?
Okay.
But I think one of the bigger things, again, kind of related to the relationship with DDR, looking at what DDR does specify that's not the unencrypted mode, right? So like in section 5 of DDR, we have, you know, the designation from a resolver name, right? So this is the case where I look up the underscore DNS SVCB record, service binding record, for the name of the resolver, and I get back the info, which, as far as I can tell, is like the same thing we're doing here. And so I want to understand, like, there's a place in this document where it says, you know, designation from DDR is when you went from unencrypted to encrypted, which is not true in that. So
Scoped.
then
yes.
if, like, what I'm curious about is, like, if we need to rephrase this, what is the difference between redirection and designation from a name?
In the section 5 case, when you have a
Yeah,
name already.
exactly. Right. So when you take those two, is there a difference?
That's a good question. I mean, I'm not gonna try and answer it because I don't like mumbling at the mic, but that is a good point, because at that point they do bear a lot of similarities. Yeah. So for one, scoping, because currently wherever we say DDR, what we really mean is the from IP in section 4, and
fine.
we have to do that. That's absolutely the case. After that, then yes, more open-ended that I don't know how we'll do yet is calling out to an implementer how this how this lives with section 5.
Right.
And that might result in changes, but I don't know yet.
So I guess in terms of, I just want to understand, like when you think of redirection. So we go from a name, and what are we validating in the certificate of the thing we got redirected to? It has to cover the original name as well as its new name?
Well, not anymore, right?
Okay.
In this case, the name's not allowed to change. So there is no new name.
Okay, so the name doesn't change. What does change? How, like, is it?
IP address or available property, because you can have added records and
Yep,
say,
that
hey,
hang off of this?
Yeah. So, do.example is who I first spoke with at 1234. And then I do EDSR and it tells me, oh, I'm redirecting you to do.example at 5678. And those could be in 2 different geolocations, right? Same server, but a redirection. Whereas I guess the section 5 case for DDR was also about expanding your available protocol options.
Correct.
Not that this can't, right? If you learn about something and you're like, oh, that's even better, fantastic. But we're actually more worried about preserving interop. Like, please don't redirect me somewhere that doesn't support what we're currently talking over.
Right.
IPv6,
Right.
IPv4, etc.
Okay. So that makes sense. But I wonder if then essentially like redirection becomes, it is a subset of designation. It's a subset of DDR that we essentially did not specify fully in DDR. That's not prohibited by, like, I mean, you could do it today essentially. So I think we get to the point where this is not really a normative change. Instead, it's like a heuristic, both on the resolver configuration side, where resolver says like, hey, when you as the DO resolver yourself receive a query for what your resolvers are, and when you respond with yourself, because you always could have responded with yourself,
Yes.
make sure that the addresses that are hanging off of that service are the ones you think are best for the client, not your own addresses.
Yes.
If that's what you want to do. And then clients, when you connect to a DO server, even if you're happy using DO, do the DDR lookup, because you're not trying to switch protocols. You're trying to see, do you have a better address for me? And so it's like, it's not new protocol mechanisms. It's a way to use things to optimally steer. It's essentially just like a heuristic algorithm.
Yeah, and I hear what you're saying, because right now the text does specify to clients like, look, if the server thinks it's redirecting you, but clearly it's taking you to the same place, you can just chill and not do in a self loop. And basically what you're saying is pointing out to resolver implementers like, hey, section 5 of DDR has you do this. When doing this, which is subtly different, here's your gotchas, because if you put the same IP address, you are redirecting to yourself, not advertising yourself. I
don't think it's different from section 5 of DDR. It's just more specific and with an intent to optimize the location that you're routed to.
Yes.
Which again, like DDR, like section 5 doesn't give an opinion on why you're doing this. It's
Correct.
just a mechanism.
Correct.
And this is like, now you have a reason to do this. And I mean, for what it's worth, there are cases where, we are currently using like DO, not quite with this, but like a DO lookup of our own resolver name, just like the A and quad A query, to re-steer ourselves to see like, oh, did the anycast put me on the bad spot, and now I'm going to move to the better spot. So like, this absolutely works, and like, I haven't used this particular mechanism with this spelling of it, but I've used the A and quad A query version of it, and it definitely helps performance. So that's good. But I one of the reasons I'm kind of pushing on this a bit is I think it can actually help simplify the document by leaning on, we have DDR already. We already did the security considerations. We already did all these other things. You can kind of explain less and just say like, this was always allowed, but this thing is a cool performance trick. And
So-
it tightens it up, I think.
So just to get to the actionable part where I work in GitHub for 3 days after the conference is
Correct.
over, when you're talking about this, what you're really saying is more direct references and less redefining of the mechanism, like lean on it and then encapsulate it in guidance as to why we're using it. Is that
Right. So instead of saying this is a new thing, say like DDR section 5 let you do this, but hey, cool trick, you can use that to steer yourself on the same protocol to a better instance, to a better set of addresses, because using an encrypted resolver can see your client IP and can do a potentially a better job of steering you.
I think we're going to have to think a little about the use case. My mind's flashing back to some feedback that Ralph gave at a previous draft version about us reusing the SUDN and conflating DDR state with EDSR state, and making sure that the server knows when the client is intending which, because there is a subtle difference. Or we just give the guidance that says, always send it back, recognizing that if it's a redirect to yourself, they're not going to treat it as a redirect. And then we need to be a little more normative with clients about not following those, because they'll happen.
So,
Right.
and partly one of the proposals would be like, we don't even need to, call it EDSR or whatever. Like, it's just, using DDR to redirect you. I mean, that's a name.
Well, other than the section 4 case, right?
Sure. Using name-based designation. Yeah. Yes. Right. It's using section 5 of DDR. Naming is hard, but
no, I meant when using section 4, like when I don't have a name yet that I trust. I learned a resolver from DDR.
Yeah, that's different.
Yeah.
That one, that one's tricky. But I guess to the point of, like, would you need a different name? I would argue like we shouldn't have it. That makes things more complex. Are there any cases where we really need a signal from the client that I am trying to do this to see if there's a better address? Because I mean, it seems like a very reasonable behavior. And like today you could have the behavior where a client does a DDR query to an encrypted resolver. Like you can do that today. Like you can do that with a quad A and quad 1. They will respond with themselves already. And clients should not go bonkers and just tear down the connection immediately, like if it gives them back the same information.
Right.
So we have this thing, and specifying that you shouldn't tear down your connection and go crazy if the address is the same is good. Specifying that if you get a different set of addresses, that's probably a hint that you should go somewhere else is also really good. But does there need to be any more signaling than that? Because like, why would the resolver not always provide what it thinks is the most optimal route for the client to take?
Is the intent of section 5 to have provided the client with some information about the name or all of the information about the name? Because that's really the underlying crux, because a redirection wouldn't want to tell you all the places you could go. It would tell you, here's where I wish you would go.
I believe that section 5 of GDR, along with kind of any resource record, like as the definition of how we do it, it doesn't have an intent to show you all addresses or not. Like that is kind of up to the deployment. But generally, my impression is like when we do a DNS lookup, we don't get all addresses that could possibly respond to this worldwide.
Well,
it's
no.
always the ones that the resolver wants you to get based on what information it knows about you.
Sure.
So I think it's a reasonable assumption that that's the case.
Manu Retail Meta, are you suggesting to redirect directly to the what I would call unicast? So typically you will get an anycast address of a resolver, and a data center pop goes down, you will go to the next one. My understanding of EDSR, where will be valuable is you will redirect the clients to a unicast, so say IP, which sends you to a specific cluster, point of presence or whatever. So if you do that at the very beginning, then clients may end up on the cluster which will go down because fiber cut, because maintenance. How do they go back to the Anycast? Because that can't go.
Right. So I mean, I think certainly that's the type of, heuristic that we need to describe in the document. Like that's what the document's for, to say, how do you correctly handle this? I think you can do that within the context of saying this really is, just a DDR query to yourself. I believe at this point, all clients, like, I'm not aware of any clients that are doing the query to DOE to intentionally redirect themselves. And so they're not going to have the problem right now of like existing ones getting stuck on a unicast. But I think what would happen organically, because I think it could happen, right? Because like, for example, like when our iOS client will do, if I've configured it to use a certain DOE server, the way we do it today is we look up the name of that DOE server on the open network with whatever the local network resolver is. We get an Anycast address. We then set up DOE. If we ask for it again to the DOE server, maybe it gives us Anycast, maybe it gives us Unicast. Fine. If at some point that goes down, the connection will time out. We'll have to fail back over to looking up the name of that DOE server on the local network. It'll give us the Anycast again. We'll go back. Like, I think it would already self-heal, but we can make that even more optimal by describing the correct algorithm.
Yeah, I think the failure mode will have to be pretty explicitly defined, because otherwise we're going to have like a bunch of clients in limbo.
Okay, and we're going to close the queue after Ralph.
So a bit clarifying question for Tommy, actually, mostly, because my understanding for this always was we are having section 4 DDR, meaning coming from an IP address, and whatever we end up with redirection, we always would have to prove the IP address with a certificate. Otherwise, we were not allowed to use. And what you're proposing is, I think, for section 5 now, or do you see that there's kind of a crossover from section 4 to section 5?
Right. I'm not saying that you cross over from section 4 to section 5. Like if you start with section 4 and that's the only way you ever got encrypted DNS, then you're kind of stuck in that trust model.
Yes.
However, if you have DNR, or if you have manually configured, because like we can have someone manually configure their resolver name to be, DNS.Google or whatever you want it to be, or we can have an application specify that's what they want. So for any of those cases where you come from a name, you're already in the DDR section 5 world. But what's not specified is what do you do about the DOE server talking about itself, and this is filling that gap. And so I think it's really valuable to do. We should adopt it, but scoping it to be like clear, because I think now that we've cut out some of the other options that we were unhappy with the first time, it's kind of clarifying and crystallizing that we can make it very tightly defined as essentially filling a hole that we previously had and we didn't specify enough the first time around.
I think we are all in agreement.
Okay, so I haven't synced with my co-chair about this, and he'll step in and tell me where I go off the rails. For a document which today is not a working group adopted document, I just saw a very active discussion in the working group as the working group helped write this document. So I'm going to go make the leap that let's just say it's adopted. Do you want to run? You want to run the adoption call? We'll do the formal adoption call.
We've got Ecker in the queue.
So we can run the adoption call again, but I'm going to guess what the outcome is going to be. So we'll run it on the list and make everybody happy. But
Go ahead, Ecker, if it's quick.
Well, I was going to say you have to run the adoption call. You can't just declare it on the basis of a discussion like in the room. So I don't just this document being adopted, but you have to run the adoption call.
yeah, point taken. So you'll make the updates.
Yes.
Some updates. You'll
Yes.
let us know, and then we'll push the note to the list of, hey, what do you guys think? Sounds good.
Sounds good.
All
Thank
right
you.
then. Thank you, Tommy.
Just chime in on that. So yes, let's get the updates, and I would love to see, obviously it doesn't have to be perfect. We're going to refine this as a working group, but trying to get as much as possible in the next revision to be clear about its relationship to DDR would help, because that will make it much easier in the adoption call to be like, yes, absolutely do it, as opposed to here's the list of like 20 nits.
Well, the great thing with an adoption call is after the group adopts it, the group can edit it. But right now, we don't have any control because only Tommy and company have to control. Okay. And also, but I think this is the fourth call we've discussed this particular document on. So for a non-adopted document, it's been getting a lot of love. Okay. So thank you, Tommy. Thank you, Tommy, and everybody. Now we're going to flip back to our morning conversation. And where is it here? You were going to do, so for those who weren't around this morning, we had a good 45-minute conversation about the motivation behind some of these drafts, particularly the draft that the Tiro and company had put up that didn't get working group adopted, and why we need to sort of look at this problem space and what's the motivation behind it. We've asked Tiro, just because some people were at other sessions this morning, and we don't want to leave everybody sort of going, well, what are they talking about? We've asked Tiro to do a very quick, like maybe a 5-minute quick zoom through of the slides he did this morning to sort of refresh everybody's mind. If you haven't seen the session from this morning, I do recommend go back and watch the recording later on, but this will give you a flavor of it and some of the core things about, especially around certificates, I think, Tiro. So if you want to come up and do it like a 5-minute brain dump about the highlights to sort of set the stage on what the motivation here is. We can talk a little bit about that after you're done, and you can take questions, and then we will open the floor up to discussion about, well, now that we've got that, what does the group want to do? And for those who weren't here this morning, we were very clear, the role of the chairs here isn't to tell you what the answer is. The role of the chairs is to help you walk through the discussion so you can figure out what your answer is. So go ahead, Tuber. And the clicker's not working, so I have to advance for you.
Sure. Yeah. Next slide. Yeah. I'll keep it quite simple that, right, there is a need for us to host encrypted DNS servers on CPEs. For instance, one example I'll take rather than going through all of them is security. We do filtering. We do filtering for IoT devices based on a manufacturer user description. So we need to identify and each device and then do the filtering for basically preventing access to malicious domains. And the prerequisite to this was like we needed secure CPE. So we already have secure CPE. If you can move on to the next slide. So there was a lot of work that happened to secure CPEs. We have hardened OpenWRT. It was part of the PRPL Foundation work that happened. Now we have Power DNS, DNS Dist, and several other DNS forwarders that could be run in containers on home routers. With that, what we are looking is we've already started shipping that, and it's already available on millions of CPEs already. The challenge is, next slide. Yeah, this is all how these CPEs are secured, just a one-on-one in case if anyone is interested. Next slide. That's the place where all the work happened with regard to hardening the CPEs. Next slide. Next slide. Yeah, this is the one that's interesting, is that we were looking for ways to make an authenticated connection possible for a client to either use DDR way of doing it or DNR way. DDR had some restrictions because we didn't find any CA who was supporting even with public IP addresses. So we were like, we had to use DNR. It was quite easy for us to provision each CPE with a unique subdomain. But the challenge with the CAs was like we had to ask for millions of certificates, and that caused a problem. And next slide. Right. So initially, when we tried some of the open CAs, they felt they realized it's a DOS attack and were not giving us the CAs. And we worked out a business equation, and we finally got those CAs working. But it eventually turned out that we are like dependent on the CA for millions of certificates and that created us with regard to refreshing these certificates and all of that, and the timeliness of refreshing these certificates. I was looking for any other way of doing it in a much that reduces the dependency on the CA. I was looking at some other proposals like STAR, which was discussed in ACME working group, but that seems to be more specific to downstream CDNs. Next slide. Yeah, there were two other options, which is delegated credentials or name constraints. Name constraints, as we know, none of the CA supports it, especially the CAP forum does not encourage it, and they don't like doing that because of auditing. We had proposed DLS delegated credentials. The working group had several concerns over using that, right? So either we stick with what we are doing today, right? Like working with the CA in a traditional way and getting all these certs and managing like what we are doing, or we do something else to make our operational aspect much more easier, right? So the question is, do you want to do something to make our life easier, or like do whatever you're doing today because we can't optimize this, right? So that's the question.
Okay. And does anybody have any questions or comments that they want to make on sort of the problem statement? Okay. So let me level set sort of our goal today. We know we're not going to come out of this room by 5 o'clock with all the answers done. It's just not going to happen. This is a hard problem. The intention is to have the conversations around the issues, potential approaches we might do to address it, and sort of get the wheels turning, because leading into Vancouver, the next IETF 120, maybe we can have something on draft or some drafts active by that point if people have some ideas. Or we have decided the problem is intractable and we're going to just bump it up to the ISG and say, well, you guys solve this and let you know when it's done, which was brought up this morning, by the way, by the crew. So that remains an option. As always with the IETF things, there's always the possibility we say we can't address this, that we're not going to because we can't get consensus. There's the option that we find some middle ground compromise where not everybody's happy, but we get a solution that lets us move forward. And then there's the other approach where we have something brilliant and it comes in and saves the day. So they're all on the table. So with that opening, let's have a discussion. How do we approach this problem? And what are your thoughts on the problem space? Is it a valid problem? Is it a valid problem to solve? And I've never had to have anybody in ADD prompted to have an opinion. And I'm kind of being shocked. Oh, Ecker, thank you for the save, Ecker. Go ahead.
Yeah.
Go ahead, Eric.
Sure. Just waiting for the Miyako to warm up. Yeah, I'm like pretty meh on this problem, frankly. This is not the best architecture I've ever seen. It's not really, doesn't really match the end-to-end design of the internet, which does not involve like having a bunch of stuff like that happens to be positioning your network, doing a bunch of things for you. So like, I'm not objecting to having that situation. I'm not trying to, but like, I don't think compromising the architecture of our design in order to make that happen is a good idea. And for that reason, I did not think that the subsource idea was a good plan. It had a number of serious security problems, and so I don't think that taking that risk is a good approach. As indicated in the previous slides, a perfectly good approach. It involves just getting a lot of certificates from a CA, and I'm sorry that it's inconvenient for the manufacturers, but I don't think that like is a good enough reason to compromise the internet architecture. Frankly, this is a relatively small load compared to like a modern CA. Let's Encrypt is doing 5 million issuances a day. So like really, this is not that big a load, and so like you should be able to find some CA to do it for you.
No, Andrew's up.
Yeah, hi, Andrew Camping. I'm just Ben Schwartz had put a comment in the chat for the mic. So since no one had stepped forward, I thought I might as well just read that out loud, which is, so Ben says, it seems that a large part of the motivation for this work was the lack of client support for opportunistic DDR. If anyone has insights into why that is not as widely implemented or was not reliable in practice, I would like to hear about that.
Thank you, Andrew.
And my no hat relay actually also came from Ben, because I wanted to bring up something that he brought up this morning, which is solving this problem is also very much akin to securing your local network for printing or for any number of other tasks that you might want to connect to services on your network. And so, perhaps the answer here is to look at a kind of more broadly scoped solution that covers not only this, but other local network uses. Go ahead, Jim.
Thanks, Tail. Jim Reed. A couple of comments to make here. First of all, I think Thierry's done a great job of identifying the problem space, and we should really thank him for that. I also agree that it's a problem that's worth solving. And I think you're also right to say that perhaps this problem needs to have a broader scope to it, because it may be for other areas around securing the local network. And if we move into that broader scope, it's probably not going to be appropriate for this working group. So my inclination at the moment would be to say is draw a line of the sand under this, say there be dragons, and say this is something that we recognise as a problem, but we don't think we can solve it in this working group, and perhaps it could be solved somewhere else. I'd like someone to contradict that if I'm completely barking mad about it.
Yeah.
Taking my hat off.
Can I take the...
Sure, but one comment for you do. My hope is that we can pull a rabbit out of the hat, Jim. And it's a hard problem, but maybe we can find a narrow solution that solves it here.
Yeah, I think there is a difference between securing other devices versus your home router. If you look at all the home routers that we have, we are using internal PKI to manage all of them. So basically they are provisioned with, we have a root CA that's installed on the CPE. It's managed by our certificate enrollment and all. Even if you look at many of the IoT devices, right, you don't talk to them directly. You go to the entity who's managing that, and through that you talk to that. So eventually it's like, even if they are using self-signed certificates, you don't get to see that, right? So the problem with, even if I'm using an app to talk to my CPE today, right, it's actually going through the entity which is managing that. I'm doing PKI to that, and that entity is using the internal certificates that it's being used to manage, right? That way, I think the problem is partially solved, that people have figured out that they don't want to use the HTTP way accessing some of these IoT devices or home routers. But the challenge is now this encrypted forwarder needs to be discovered and used by endpoints, and there is no pre-provisioning that has happened between the endpoint and the router, right? And we need PKI to work there. And I don't see how that pre-provisioning step can be bypassed here for us to do anything there. So it's a problem for other devices, but it's a problem that could be solved by different techniques. This problem cannot be solved because there is no bootstrapping mechanism.
Okay, Eric Vink, talking as the AD responsible for this working group, like I said this morning, for the benefit of the people that were not there, one outcome of the discussion here is that the problem is broader, maybe, and then we may want to get above and creating a working group on this. This may be a real outcome. Don't forget this solution.
Anybody else? Eric was last in the queue at the moment. I don't know about Glenn, but at the moment I'm feeling like we don't have a clear sense of direction about what to do about this. Welcome back, Tommy Pauly.
Tommy Pauly Apple. Yeah, I agree about not having a great sense of direction here. Just wanted to respond to Ben's comment that was relayed at the mic and kind of ask a question for clarification. So, at least on our platforms, we do support opportunistic DDR to the level that if just the IP address matches, we will use it. We do require that it is a certificate that we can trust, but we will use it at that level, and that is what's described in the document there. So that doesn't solve all your problems for actually getting the certificate, but that is what's described as opportunistic DDR.
Right.
Ralph, please.
Yeah, maybe also reiterating what I said earlier this morning. So, I mean, I would like to have this problem be solved, because it would be good if we have sort of a the capability of actually using the CP in the home to do stuff and having an encrypted DNS connection to it. From, again, I mean, it's not the Apple device, but they are currently, it's not universally supported, the opportunistic stuff. So if opportunistic would work, that would be a solution, but unfortunately, that's not the reality. So maybe we'll kind of work on something that eventually will work.
Great. Thank you, Ralph. Ecker?
Yeah, I mean, I think it's like really kind of important to sharpen what this problem we solve means. As I said when I was speaking earlier, this problem is solved. Go get certificates from a CA. And like, so like the underlying problem statement here, if like the problem statement is have the CPEs like be in the loop with a valid cert chain, that is the answer to that question. And so like the reason people do this, so like if the problem statement, so the problem statement is we find that too inconvenient. Let's drill into that. But like that's the point of disagreement, not like any of these claims about whether the CPE should be able to do this or not.
Kira, did you want to respond to that with the comments you made this morning?
I didn't get, is there a question? Was there a question?
Well, so sorry, I was prompting you. So this morning, when we talked about certificates, you went through some scenarios about practical experiences you had in obtaining certificates for a large number of CPEs and the challenges there. And I thought maybe the group would benefit from hearing that again.
Sure. At least when we started this, right? I mean, we were trying Let's Encrypt, right? And because it was seeing these so many subdomains, and we were sending all these requests using Acme, they basically started denial. And then we contacted them, and they realized that they were under some sort of DOS attack where someone was creating so many subdomains with random names, and then coming and asking them for cert. So basically, we ended up with some CA we had a business agreement, and basically the biggest dependency is like we are managing those millions of CAs, and then every X number of days we go and ask for a new certificate and all of that, and meeting those SLAs with regard to the time duration before which we could get a cert, and then pre-provision that again on the CPEs. So that turned out to be like a lot of dependencies. And I saw like lots of work was happening with regard to like, especially with CDNs and downstream CDNs, there's a lot of work happening with regard to star certificates or TLS delegated credentials, which seem like much smaller in scale, and they seem to have figured out a way to do it in a way that reduces the dependency on CA, right? So I was thinking, why can't we try any of these techniques that was applicable there and use it in our deployment? So that prompted me for this solution, right? And if that worked for downstream CDNs, why won't that work for this deployment?
Okay, well, I think it gets like star. I mean, there are two different things here. One is star, which is a way to like make, you know, is a way to make the load of having individualized certificates easier. And I mean, perfectly like that's between you and the CA. But DCs have an entirely different threat model, the way you're trying to use them, than individualized certificates, because everyone has the same name in the way you're trying to use them, and that's a entirely different set of security properties that are bad. And so, like, you know, I mean, like like the inherent property is each CPE is its own thing and has to have its own security boundary, and means it has its own credential, and that means you inherently need to manage a credential for each CPE. And like, there's no way around that if you're gonna have a secure system and not have a single point of failure. So like that's a management problem, but like the management problem because they're different entities, they're not the same thing. And I mean, and CDNs just like CDNs have to have like a different certificate for every like server they're hosting.
Sure. Even in our case, we have like unique public-private key pairs for each of the CPs. It's not like all the CPs have the same public-private key pair.
No, but they have the same SAN. The SAN is the problem.
And why using the SAN is the problem?
Because it allows someone who controls one CPE to impersonate another CPE because that is the same SAN.
Okay, but that CPE would have to know your exact same credentials as your other CPA, right? Otherwise, you would not even.
No, they're all going to have the same. What do you mean? They're all going to have the same domain name. That's the whole nature. That's the whole reason you're trying to avoid is having different domain names for each CPA, right?
Yeah.
And so, like, but that's the source. That's like that makes them interchangeable from the web perspective, from the CL's perspective.
Got it.
So I guess I just don't see any way around having like a different, like non-substitutable credentials for each CPE, because otherwise you just have one giant CPE, like, you know, is in the same trust boundary.
Yeah. Lars, please. And Andrew, do you want to come back to the queue? Or?
Lars, so I agree with Ecker, unsurprisingly, right? So it seems like DDoSing Let's Encrypt was maybe not the smartest idea. So I would encourage you to maybe go back, because they do handle certificate loads that are larger than this, and maybe have a conversation with them about what it would take for them to handle a case like that, and maybe even throwing them some money. Just a thought.
No, we have already done that, right? I mean, that was a post effect after that, right? But the challenge is, are we going to still manage those, or is there a better way of deploying this? Was the question back to the working group.
So I think, I mean, Ecker made a much longer and more elaborate case that I think that the better way to deploy this is actually with individual certificates. You might want an easier way to deploy it, but the better way is actually doing the right thing and getting each box its own certificate. And it can be done, it just might be more inconvenient.
We are back to an empty queue. Oh, and Mr. Campling is back.
Hi, Andrew Campling. So I think, Thierry, what you're saying is that you've identified some solutions, but they're just not suitable.
It's not suitable, it's deployed, but it's like, you have a tight dependency on the CA for all this. We're able to scale up and do all of this, but you're like, the number of interactions with the CA are much more higher, right? Because you are managing all those millions of certificates. So, and I was looking for ways to reduce that dependency, if that was possible at all, right? Otherwise, we're good with this model and we can continue doing that. I was looking if there is a way to optimize that.
And also, having just come from the DNRG group, putting even more centralization into a design feels like a bad thing. So perhaps you might just want to reframe the question, because it seems to me like, yeah, okay, if these aren't the right solution, perhaps just being clear what the question is that the group ought to be thinking about working on will be helpful.
Right. So we are currently managing individual certificates on each of these devices, right? Just like, and then I was looking at other mechanisms to optimize that dependency. So if you had done name constraints, for instance, right? I don't have to go to the CA always, right? It's the entity which is managing this service would have managed all the certificates by ourselves, which gives us a lot more control than going behind the CA. Is that a possible deployment, was the question back to working group. That is there any alternative? We have done it in a particular way, right? It works, right? But is there a better way which doesn't impact the security but gives us a much more better control, is the question.
Go ahead, Wes.
Wes Hardiker, speaking solely for myself because none of my employers will like what I'm going to say. So I think your biggest problem is that you only have two problems you don't like. So I'm going to give you a third that nobody will like, which is in a completely signed reverse tree, you could do Dane.
In IPv6?
You know, more of the reverse tree is signed than you'd think, actually. But you got to get it all the way down. That's the
That's where all the turtles are. Go ahead, Glenn.
Yeah, hi. So as chair, I'm sort of stepping back and saying, okay, what's the next steps here? It sounds like we have potentially a opportunity to frame a problem, and it sounds like we've teased out a problem set here. So maybe one exercise to do is it needs to be documented and captured as a problem statement in an ID so that we can iterate around that. And it may not be this group that iterates it. It may be a different group that needs to chew through it. But I think maybe we've gotten to the point where we can capture the core problem statement based upon the conversations we've had here today. So that's actually really great progress, I think, towards the end goal. So if we were to do that, and if people were to volunteer to help write that, that'd be really awesome between now and Vancouver. What else would we want to do? What other next steps do people think are reasonable to help move this problem down towards an eventual decision or a resolution potentially? Any thoughts from the audience?
Yeah.
It's me again. So I mean, I guess I would observe that like star, name constraints, and what you're doing now, none of them require any activity from Acme, from the ADD, right? They are just simple use of the web PKI. The web PKI, the way it's always used, right? So, the only thing that so like I think like if the, and by the way, this is like not the only scenario in which there are like manufacturers want to have like a giant pile of like of like devices, each of which has their own certificate, right? The only thing that required like support here was the DC thing. So I guess what I would say is like there's a separate problem statement, which is like manufacturers like to have like a giant pile of certificates, like one for each device, and they'd like to issue them in some more efficient fashion. And I think that's like a reasonable problem statement, and it probably like goes to like Acme or to all dispatch, but it's like not unique at all at DNS. I mean, it's the same thing as like if I have like I have light bulbs, it's the same thing, right? So I think like my sense is that problem has been kind of like delved into a bit, and like nobody was like super happy with the results, and it's like kind of how you got star. But like that's I think that's the place that the problem that you framed is like not really just go for this working group.
Yeah, that makes sense. I mean, at least the name constraints, at least the 5 or 6 CAs that I spoke to this, they were not willing to support that. I could check on the star certificates at least, but I have not seen any willing that they would want to support name constraints at least. I can check with them.
Yeah, I don't know either. Yeah. I mean, there's some talk of technical restrictions, but I don't really know. Unfortunately, we don't have the right PKI people in this room.
Okay, we're at the end of time, actually. Are we to 4:30 or 5?
5.
Oh, my bad.
So you can continue arguing for another 33 minutes.
Maybe we should be at the end of time.
I mean, look, the queue's empty right now. We have one proposal of writing down a problem statement document ahead of Vancouver. Are there other actions that people think we should be considering doing between now and Vancouver to help the discussion? So does anybody really like, do you think this idea, this proposal of writing the problem statement down and describing it is a terrible idea, and you want to come to the microphone and say, please don't write the problem down? That's not going to solve anything. I always good to ask the counter question. But it sounds like we may have something to do here to help, maybe. Yes.
We could write the problem and the way it's deployed today, and maybe check with CAs if they can support star certificates and if they can, or name constraints. And then if any of them agree, we can come back to the working group that this is an optimization that could be done.
Well, in particular, I was also thinking maybe from this morning session, there were some great comments about certificates and expirations and that kind of thing, to include that in the problem statement document about the different dynamics of certificate models might also be really good material to iterate around to discuss. Andrew.
Hi, Andrew Campling. So I wonder if it would also be useful, in addition to writing down the problem statement, to maybe expand a little on what Tira has already sort of put on the slides, to explain why the currently available solutions are not attractive or not viable for some reason. Just to be, because I think some of the discussion we're having is because people are saying that there are ways you can solve this. But I think from the discussion this morning in particular, Tira is convinced that they're not.
Yeah, no, that in fact is my point of including that elements in this problem statement document. So it isn't just like, here's the problem, it's here's the problem, and here's the discussion that's gone on so far around the problem and the different solutions that have been looked at and their strengths and their weaknesses. So we have a meaty reference that we can chew against.
Not only here's the problem, but here's why explicitly it's a problem that we need additional work on.
Yeah.
Yeah, Jim Reed, you're up.
Thanks, Dave. Back again. I think we've got another issue just to sort out in terms of working group dynamics here. We haven't sort of had a discussion about this topic, but we don't seem to have reached any kind of resolution of what we think the next steps might be. The problem statement idea, I think, is a good one, personally, but we've had no view from the rest of the room or from the rest of the people that are here. So maybe we should take a hum on the basis that working on this problem statement is a good idea with a view to having a further discussion at the next IETF meeting, or there may be others in the room that think this isn't worth the bother and there's just indifference to it. So I think we need to make some kind of positive decision about whether we want to continue with this or not. This is me pretending to be a working group chair.
Yeah. Be careful, you might be.
Lars, along the same lines, so I would appreciate if somebody would highlight where you believe this fits in the charter, because I look at the charter and I don't quite understand how this would fit.
How we got here, Lars, was we had a draft submitted and discussed repeatedly at the things which failed working group adoption call. And it failed working group adoption call because we hit an architectural sort of approach where a large portion of the ADD group thought the work should be adopted, but we also had a set of strong voices who said the work should not be adopted.
Sure.
And so the actual thing that we come out of here with may not fit to this group's charter, but at least if it doesn't fit in the charter, then potentially we can define what it was that needs to be done and feed it up to somebody else to work on. And while we sort of punt on moving forward on the draft as it is now. So
yeah, I mean, you're getting pretty meta here, right? Basically saying the working group can define things for other working groups to work on. That's not really.
We're absolutely not defining what other groups can work on. But if we can't get the document over the goal to get adopted and worked on by the group, maybe we can capture the reasons why it failed and then move on. Does that make sense?
I'm just looking at the 3 bullets in the charter, and this is a very broad interpretation of what they let you do.
So just stepping in to actually partially maybe answer that, to tie in with a discussion that's been ongoing in the chat between Ben and the Tommies. Some of this would go away if we all supported opportunistic DDR, such that we would just trust encrypted DNS when we find it available on the same IP address with 0 checks, which the RFC allows, except none of us do it because we don't want to. And you know what? I'll let you explain that on the mic because that confuses me. Ideally, we can use DNR where the network tells us all the metadata we need up front, and then we can authenticate it. And clearly, how we authenticate it is very complicated. But if we can solve this problem, then we greatly improve the value of and the broadness of adoption of DNR that this work produced. So I'm not any kind of hat wearer, but that's why I think this is important. And I do think we should work on this. I don't pretend it's going to be easy, but thank you.
Yeah, at least at the time I was working in my previous organization, at least the ISPs who wanted this solution from us, right? They were not interested in opportunistic encryption. So they wanted the verified one to work, probably because of the lack of support from the clients. If all the clients do support it, right, I think that could make it quite easy to do this.
And I'd like to respond back to Lars. Now I've had a minute more to think about it, Lars. If we do not have a solution we can come up with here, then we will have failed our core charter, which is finding a discovery mechanism for clients, because there's a set of environments here that today can't participate in the discovery of encrypted DNS resolvers successfully. And so this is sort of It's at the core, but I get you also pointed. We don't want to go too far with that. So that said, shall we do a hub? So Tommy, you want to comment?
To clarify on this, Tommy Polly Apple, what you're saying about people not wanting to do the opportunistic, can you explain? So if a CPE is using a private address space IP address, they're not going to get verified to work. They're not going to get a certificate that covers 192.160, like that's, or a 10 dot address. They're not going to get that. So, what we support for the opportunistic is, yeah, if you are running your encrypted resolver on that same address and you're in private address space and you have a certificate with any name in it, that's just like a non-expired cert that we trust to some root, and I don't care if you use the same name and the same key across all of your CPEs because I can't verify it. Yeah, I'll use it. That's opportunistic. So they don't want to do that. But what do they want to do? They want to do DNR instead, or they can't do verified
wherever
DDR.
authenticated discovery was possible, the DDR way of authenticated discovery or the DNR way of doing it.
But you can't do so with private address space. The best you could do with DDR is what we do let you do, which
Yes.
is like opportunistic, but you still have a valid cert.
Right.
That's like valid, but not related to any name. So it's like, I know we're complaining on chat about that. Or you do DNR, and then you're fine.
Right.
So are they okay with either of those? Because if they're okay with either of those, at least they could work with all macOS and iOS devices today.
I need to go back and check at least on the DDR part, because when I was querying, at least they wanted a verified discovery. But my understanding of DDR opportunistic is we could use any cert and we could just use any private IP address and it would still work, right? It would even work with self-signed certificates. It wasn't right. No.
We could. One could do that, if I may.
It can, yes. The text of RFC 9462 essentially says that if you want to support a client may support opportunistic, by which it's not at that point required, or you're not supposed to check the name at that point, but you may check whatever else you want. And that's what Apple is doing, is they're checking other things like, does it parent to a known root? But that is optional. You could be RFC compliant doing that, or by simply ignoring everything about the cert, let it be self-signed from 20 years ago. That would be RFC compliant as well.
Yeah, but the challenge is, right, I mean, we do all of this and clients reject that, right? That was the question, right? I mean, at least opportunity DDR did not work for us when we tried it out. At least with Microsoft, it didn't work, if my memory serves right. Yeah, I probably worked with you, but we wanted all the clients to work, right? So we had to eventually figure out.
Yeah, go ahead, Ecker.
Well, I actually have a question for Tommy, which is, why do you check the certificate is valid if you don't care the domain name?
It's not. Yeah, it's not really a security measure. It's just like, it's. I mean, like, less chance it was like an accident.
Right.
Yeah.
Let the note show that Tommy just had a giant shrug.
Yeah. So I guess I sort of want to revisit to like Lars's question. Like the problem statement is, I have a big pile of devices and I find it inconvenient to manage all the certificates individually for them. That is not in the scope for this working group. That is just like something else. That's just an inconvenience of like the deployment model, but it's not like the scope for this working group. And like, I just don't like, I mean, I guess I just don't understand like what this working group would be doing, producing a problem statement around that. I mean, Eric's here. Eric's is here. So like, Eric, if you read the charter differently.
Okay, Mike.
I just want to point out a design from a completely different space that is trying to solve a similar issue. If anyone's familiar with the product Plex, the way they get certificates to work on an install is that each instance gets a wildcard search for star dot its unique identifier dot plex dot direct. And then on their DNS servers, they have a kind of weird mapping where embedded IP address dot anything dot plex dot direct will resolve to the IP address you put in the host name, which means you can stick the IP address in the host name and generate a URI where the DNS will resolve, the certificate will match, you're perfectly happy. If the CPE is willing to work with some services out on the internet, they could take a similar approach, and I don't think we need anything beyond what 9463 already has. It can be built. I don't know if we need to define something new.
Leslie, please.
Leslie Daigle. I want to go back to Glenn's earlier question about whether or not there are any objections to writing down the problem statement. I think the problem statement is actually what you need. The problem statement that Ecker keeps reiterating doesn't sound like a problem worth solving, but I'm not sure that that's what everyone else thinks the problem statement is. So I would suggest get agreement on this problem statement before you worry about the solutions.
Okay, so Eric Vink again. First, as an individual contributor, as I wrote in the chat, I am the proud owner of a CPE that renews its certificates every 3 months through Let's Encrypt, so the stuff exists and doesn't break the internet. The other point, as an AD now, for sure, if we want to go in this job, we don't have the right expertise in the room, I mean, except for some people that do have the expertise in the room, right? So this job will probably not be done here, not only because it's out of the charter, that's for sure, that's what I was thinking before, but also outside of the expertise of the working group. Now, having some people in this working group working on an individual document to document the problem statement as an individual document, I think could be useful for maybe a potential both if we decide it's one way of doing it. Again, individual document in this one.
Thank you, Eric.
So why don't we ask you if we want to do individually or with the group?
Yeah. Do you want to go ahead with that show of hands then?
So let's try to do a show of hands now. So if you're not on the local tool, here's your big chance to log in and join the local tool so you can participate. Do a show of hands of how many people think we should be doing. How did you word this? You read what you word.
Would you like to see this problem statement draft on the CPE issue? And to be clear, that does not mean, you know, if a draft is produced that we're going to adopt it in the working group for further development of the draft. It's just, does it help focus us on a draft that could then eventually become?
Is it open?
It is open, isn't it? Yeah.
I would love to have Meetic or Tracking who said yes, and I said yes, by the way, so we can put the name as a potential contributor to this individual draft, right?
I will say that, you know, with 69 people in the chat, the sense of the people who participated is very clearly, yes, let's please look at a draft for this, Chiro.
Okay. So I think maybe we're done. Thank you, Tira.
Thanks.
Thank you, everybody, for your time, your patience. But mostly, can I say thank you to everybody for your respect for each other? You know, AD in the early days, we kind of dusted things up a little bit, but we came to a place of kindness and respect to everybody. And I really saw that present and operational here today in this discussion. It's a very sensitive topic, which people have a lot of passion for, and we did really well. So thank you for being such a great working group. I'll see you in Vancouver.
Seconds after the meeting's over.
You want to pass over there? Everything else to get back here. Yeah, I think their batteries are running low on it.
Maybe that's what this is.
Ah!
Well, that's what those are. I agree. I mean, I saw this with the tag and all. I didn't know that that's what it was stored in.
All right.
I think especially when the red lights. Okay, Edeco is shut down.